All right, welcome to Number Sense Academy. And today, or in this video, we're going to talk about finding the point of intersection or the solution for a system of linear equations using the method of substitution. But before I even get to that, or before I even get to solving any examples or doing any examples, I want to emphasize when and where you would use substitution. So the question is, when would or should you use substitution? Well, here's my rule, and I think other folks would agree. So you use substitution when you can isolate for one of the two variables okay, so that means you get either x equals or y equals. So you can isolate for one of the two variables without having, I'm going to say, misbehaving decimals or fractions on the other side. All right. So what do I mean by that? If you end up with, say, you solve for y and you end up with 3.1415x plus 3, like this is not fun, right? It's just extra work. It's not that it's difficult to manage, it's just extra work. And depending what you're subbing into, like what if you're subbing into a fraction, that could be or a fraction with you're subbing into for y, but the coefficient is a fraction or another decimal. Yeah, it's not too fun. Or if you have a fraction, like if you have x equals what after you isolate for x equals 5 over 12 y, again, minus 8. Dealing with this 5 over 12y, that's going to make your life a lot more difficult. Unless you're subbing this into, say, 12x, right? Well, now you have 12 times 5 over 12. Well, that's really, really nice, okay, because the 12s will cancel out. But I'm going to assume that if the likelihood that you'll find this on a test is going to be a little bit unlikely. I'm just going to guess. I don't know if it's true. But if you're gonna end up with a fraction or decimal, just don't use substitution. If you're gonna end up with isolating a variable and you end up with a fraction or decimal on the other side, just go to the other method of elimination. Right. So now I say that, but sometimes there's a bit of work to get there. So if you have x plus y equals 3, yes, use substitution because you could get x equals 3 minus y, or you could get y equals 3 minus x. So you could sub for y. All right, so that's nice and fun and easy. If you have 2x plus y minus 3 equals 0, this is also nice and easy because we got the y right here. We could write this as y is equal to negative 2x plus 3. Again, nice and easy to work with. We like nice and easy to work with. If you have 2x plus 4y is equal to 6, oh, well, these aren't by themselves. Yeah, that's okay. If you just divide by 2, so sometimes you got to go out and look for these opportunities where you can reduce to lower terms and then get what you want. So we end up with x by itself plus 4y, not 4y, plus 2y equals 3. And now I can get x by itself. So 3 minus 2y. Okay, there's an opportunity there. Or if you have, so sometimes you might just want to check if you have the opportunity. So what if I have 2 over 3x plus 3 over 4y equals 5, right? Well, I want to get rid of these fractions. So I need to find a multiple that could take care of these. So I know 12 works. So I'm going to have 12 times 2 over 3x plus 12 times 3 over 4y equals to 12 times 5. So what happens? I'm going to multiply 12 times 2 is 24 divided by 3. I end up with 8x. Then I have 12 times 3, which is 36, divided by 4. I end up with 9y. And 12 times 5 equals 60. There is no opportunity here. Okay, there's no opportunity here. So I'm probably going to have to end up using elimination. But let's look at the last one. What if I have 0.7, so I have 0.7x plus 1.4y equals 4.2. All right. I can raise this to I want to make these whole numbers. Always make your decimals whole numbers. Make decimals whole numbers or integers. All right. So the way you do that, you have to make the decimal with the most. Figure out how you could take the decimal with the most places and make that a whole number. And whatever you do to make that a whole number, you have to do to the other terms. So what I mean by that is if I have a number, say 5.6853, and that's the number with the most decimal places in the equation, this is going to require multiply by 10,000 to make this a whole number. Everything else has to be multiplied by 10,000, right? So continuing this frame, to make, I noticed that 0.7, 1.4, 4.2, they all have one decimal place. So I only need to multiply by 10 to move that decimal place. All right, so I end up with 7x plus 14y equals 42. But here's the other thing. I could divide all of these by 7, and I end up with x plus 2y equals 6. And of course, I could write this as x equals 6 minus 2y. So now I could use substitution. So the point is, there could be a bit of lead work that you have to do before you get to a point where you could use substitution. Now, if you get comfortable with both substitution and elimination, just pick the one that's going to get you there faster. So all this work I did for the decimal might be necessary to get rid of the decimal, but your other equation might have decimals that have a 0.7 in there. And this will make sense when we cover elimination. So only do what you do. Only do this if you absolutely have to. All right. So now let's jump into some examples. So our first example, we have x minus 3y is equal to 2. And then we have 4x minus 3y is equal to negative 10. Now what I'm going to do, I'm going to label these equations. I'm going to call this equation 1. I'm going to call that one equation 2. Now right away I see the opportunity to substitute or to isolate for x, which means I'm going to be able to use substitution for this equation. So to make x by itself, I'm going to write a little note that says I'm going to isolate for x in equation 1. And then I'm going to actually do it. So that becomes, so I have x minus 3y equals 2, and x becomes 2 minus 3y. So I have that done, which is great. So my next step now, I'm going to take this x equals 2 minus 3y, and I'm going to sub it into equation 2. So I'm going to tell myself that I'm going to sub. Actually, no, before I get there, what I'm going to do is actually label x minus 3y as another equation. Now, keep in mind that equation 3, which is x equals to 2 minus 3y, is the exact same thing as equation 1. They're just written differently. But I'm keeping order of what I'm doing. So what I'm going to do, I'm going to sub 3 into 2. I can't sub 3 into 1 because 3 is 1. All right? So let's do that. So when I sub 3 into 2, what I have is 4 times 2 minus 3y minus 3y equals negative 10. Okay, so what I'm saying is that if x is a basketball, 2 minus 3y is that exact same basketball. All right, so now I'm going to use my distributive law to multiply these out and get a value. So I have, is it 2 minus 3y? It's not 2 minus 3y. Big mistake. It's 2 plus 3y. Important to keep track of that stuff. So 2 plus 3y. So I have 8 plus 12y minus 3y equals negative 10. I'm going to bring all my like terms together. So I have 12y minus 3y equals negative 8 minus, or negative 10 minus 8. So this becomes 9y equals negative 18. Divide both sides by 9. And y is negative 2. So now, to finish this up, because I found y, which is excellent. Now I need to find x. So what I'm going to do, I'm going to sub y equals to negative 2 into equation 3. And the reason why I'm doing that is because this is already solved for x. So you have to make those calls yourself. This is already solved for x. I could sub it into 1. I wouldn't sub it into 2 because I already used 2. Sub it into 1 to test it out and make sure that it works. So, obviously if it works for 1, it's going to work for 2. Right? So because 3 is already solved and 3 is 1, I'm just going to sub it into 3. So this becomes x equals 2 plus 3 times minus 2, which is 2 minus 6, which is minus 4. So therefore, the solution to the system is negative 4, negative 2. And as a good practice, I'm just going to check to make sure that this is the case. So let's grab equation 3. So I'm going to sub x equals negative 4 and y equals negative 2 into equation 3. I could sub it into equation 2 if I like, but equation 3, like I said, is nice and soft. So what I have is negative 4 is equal to 2 plus 3 times negative 2. So 2 plus 3 times negative 2 is 2 plus negative 6, which is negative 4, and these are equal. Okay, so boom, boom. So negative 4 minus 2 is a solution to the system. All right, next example. So I have 3x plus y equals 8. And then I have 2x minus 3y equals 9. Right away, I see the y standing out by itself. So again, I'm just going to follow protocol, label the equations 1 and 2. Then I'm going to solve equation 1 for y. So that becomes y is equal to 8 minus 3x. and then I'm going to name this equation 3. I'm going to sub 3 into 2, exact same pattern as we did last time. So now I have 2x minus 3 times 8 minus 3x equals 9. Then I'm going to run through this and solve. So I have 2x minus 3 times 8, which is minus 24, minus 3 times minus 3x is plus 9x equals 9. I'm going to bring all my variables together. I have 2x plus 9x equals 9 plus 24. 2x plus 9x is 11x. 9 plus 24 is 33. Divide both sides by 11, I get x equals 3. So now I'm going to sub x equals 3 into, again, equation 3 because it's already solved. I have x and I need to find y. So it becomes y is equal to 8 minus 3 times 3. 8 minus 9 is negative 1. So a solution to the system is 3 and minus 1. And of course, we want to do a quick check to see if this works. So let's do a quick check. So I'm going to do something a little bit difficult. I'm going to sub x equals 3 and y equals negative 1 into equation 1. Or maybe let's do equation 2. So I have 2 times 3 minus 3 times negative 1 equals 9. So 2 times 3 is 6, minus 3 times negative 1 is 3. 6 plus 3 is 9. 9 is equal to 9. So this is good. They work out. All right, let's do one more example. And in our last example, we have y is equal to negative 3x plus 12. And then we have x is equal to negative y. So this is an easy one to pick from. We could just pick x equals negative y and sub it into, replace x in equation 1. Right? We just take this and put it here. But I want to show you something a little bit different. I'm gonna isolate for y in equation 2. And you're gonna say, why would I want to do that? Because I want to show you something different. So if I do that, see, I have x equals negative y. I want y. So this means I have to divide by negative 1. So I have negative y is equal to x. There's a 1 in front, so I'm going to divide negative y divided by negative 1 is equal to x divided by negative 1, which becomes y is equal to negative x. Which makes sense. If x is equal to negative y, then y is equal to negative x. I'm going to call this equation 3. Now I'm going to stack equation 1 and equation 3. So I'm going to put that in a different color so we see. So now what we have is y is equal to negative 3x plus 12. And then we have y is also equal to negative x. So this is a different type of substitution. Remember what I said? If y is a basketball, that means the other y is a basketball. So if y is negative 3x plus 12, then the other y and the other y is negative x, then negative x is negative 3x plus 12. Right? So that means negative x is equal to negative 3x plus 12. So we know that because y is equal to y, then I could just set these equations equal. Set the equations equal to each other. So what does that look like? Because y is equal to y, then that means negative x is equal to negative 3x plus 12. So now I just solve. I still have my one variable. So I have 3x minus x is equal to 12. So I have 2x is equal to 12. And then x is equal to 6. And let me just erase all of this so I could use up this real estate. All right. So now I'm going to follow my rules. I'm going to sub x equals 6 into equation 2 because it's so easy. So much easier. Or no, let's sub it into equation 3. That's even easier. Let's sub it into equation 3. So I have, for equation 3, remember we have y is equal to negative x. So y is just equal to negative 6 because it's just a negative of x. And we're saying that our solution is equal to (6) and negative 6. And then let's do a quick check. So I'm going to use equation 2. So I'm going to say it says x is equal to negative y. X is 6. The negative y is equal to negative 6. The negative of negative 6 is 6. 6 is equal to 6. And voila. All right, so that's it for substitution. We do have a video on elimination, and this will kind of round out your knowledge on how to choose which equation to, or which method to solve your system of equations. Thank you.